Well, hello everyone. This is KP the Math G once again. Yeah, it's been a while since I've done a YouTube video. This will make my 145th video. But we've been working outside, doing a lot of outdoor work, and doing a lot of traveling too. Got a lot of family to see. I've got a daughter who's expecting a child, and I've got a son whose wife is expecting a child also, both in the month of October. So we're still a few months away, but we want to see them once in a while as they're expecting and everything. And she had a shower we were getting ready to go to, a baby shower. So a lot of events happening over a period of time, and I apologize. Well, I don't apologize for that trip. That was worth to see my daughter expecting and all, and see the gifts that she got and everything. It was really nice. Well, let's get to the problem here. This is a lot of times we get problems, and I've been noticing that ever since I've been doing problems from 1997 or 1998 to this, I've been seeing a lot of something entering in and something leaving. Water enters into a tank, but it leaks out of the tank at a certain rate. Enters in at a rate, leaks out at a rate. And this is fish entering and leaving a lake. I take it that these fish are being caught and they don't leave on their own. That's a bad joke, okay? So anyway, they're probably getting caught, okay? Okay. All right. They are entering the lake at a rate E at T, which is 20 plus 15 sine pi T over 6. They are leaving at a rate, this is a rate, of 4 plus 2 raised to the 0.1 T squared. Okay, these people who come up with these functions are it's really good. You probably have to experiment with that just a little bit to kind of see what values you're getting and all, and where the graphs intersect and so on. But anyway, that's right. So just so you get an idea, and if whether this is your first or second year teaching, or whether you are a student, maybe you're getting ready for the up and coming year. You've already had this, but you're going into BC, the BC part of the calculus. Good. And if you're just taking calculus, good. Just regular calculus, that's all good. The number of fish entering is going to be a definite integral from A to B. And the number of fish leaving. So look at the units here. For the rate, it's going to be fish per hour. Number of fish leaving, it just says fish. I just said fish. Well, I should probably say number of fish, but no per hour. See what I'm saying? Alright, so here's part A. We're probably going to do part A and B, and maybe if we have time, maybe part D, and we'll reserve part C for another time. I don't know. I'm looking at this all. Yeah, we'll probably do C at another time. Okay, well. Okay, so first of all, we look for keywords, and one of the keywords that sticks out in my mind immediately is how many. So I get this feeling I'm going to have to do a definite integral when I'm trying to find how many fish, and then it says enter. Alright, well, they enter the lake. I want to find out what my integrals are, or what my interval is from T equals 0 to T equals 5. So I already have everything that I need to solve this. Let me see if I can find something to work with here. So we're doing a definite integral from 0 to 5. And now it would be nice if you were to put this in Y1 maybe, and put this in Y2. If you have a Y3, I've got a Y sub 0 and a Y sub 1. It doesn't matter. But if you have like a Y1 and a Y2, I would suggest even a Y3 would be, you're usually going to get this this type of question, but the rate entering minus the rate leaving, or how many fish. Okay, and we do have a problem or two like that, so just be aware of that and what those graphs look like. Okay, well, first of all, entering is going to be this. It's going to be, well, I can put the whole thing in there. Alright. 15 sine of, what is it, pi t over 6, and close it up and put dt there. Or I can simply, if I already say, let's say I have this one in y sub 0, actually I have this one in y sub 1. Alright, so maybe I can do y sub 0, well, I'm sorry, my bad. Anyway, integrating from 0 to 5, y sub 0, d, and then they're gonna have an x there. Okay. Okay, so either way you want to go with that, you can. If you put this in, say what I've got it in, like y sub 0, like I have it, when you get ready to pull it up, you can pull up this integration symbol here, and then just start putting your limits of integration right there. And then if you can get into y bars, okay, some people have bars and y bars. I can get right straight into y bars, but anyway, y bars, and then you get this long list: y0, y1, y2, y3, y4, so on. I got mine in the y0, and that puts all of this in there. You don't have to copy this out. Okay, so then once you put that in there, and let me get my phone, because my calculator is on my phone. Sorry about the delay there. I apologize for that. Oh no. Okay, now I have figured this out all before. Let me take a look at that, and maybe I didn't put that one in there, but let's put it in there anyway. Now, again, I've got to pull up my, I did probably, but I can't scroll back far enough back to get to the first problem. So let's go ahead and put this in here. So I'm going to put math, and I'm going to put that definite integral in there. Let's see. Okay, I've got it now. Limits of integration from 0 to 5. Okay, now I do want to do the y bars. Alright, y sub 0 is what I've got it in, and it's going to show dx like this. Alright, then I hit enter, and I get my number, and it says round to the nearest whole number. Okay, so 153 is what I've got. Okay, so 153.4, I would say go ahead and just go with it's about equal to 153 fish. And you might want to put the units down, and you want to make sure you understand what you just found, maybe. Okay, That's how many fish enter. Now, a lot of times I do know that when we trout fish, that there are fish that are stocked. They're called stockers. People bring them in a truck, the way I understand it, and they unload the fish, the trout. I would imagine way more than just 153. I would think probably literally thousands of them would go in there, hundreds at least. And that makes it easy for you to catch trout. Of course, now the stockers used to be just about like this, but now they're pretty good sized stockers now that they're putting out there. So you do catch pretty good sized trout. Okay, well, anyway, be that as it may, that is part A. Alright, let's look at part B. I just may try to leave this up there so we can do part B. I hope this helps, that, you know, maybe if you're not used to seeing that whether you're a teacher or not, you know, a student, even teachers need some review once in a while. It does help to see this. I really believe that with all my heart. I'm not here to say do a online workshop, but this is really helpful. I believe so. Alright, let's look at number 2. Now we get the average number of fish that leave the lake from midnight to 5. Okay. Alright, so the average, we want to find the average. Let's see if I can find something. I always lay stuff down. Yeah, right here. Alright, so B part is find the average number of fish getting crowded up here, isn't it? The fish that leave the lake. Alright, and to make matters easy, we're going to just use the interval there. Okay, like that. You may see something that looks like this, maybe. Alright, and of course this is in hours. Now, what words stick out to you? Absolutely. Average number. Now, that's a little different specimen, isn't it? When we talk about the average number of fish right here. I have a lighting problem up here. No, it's not a ghost. But this light bulb keeps wanting to go out, and it's not that the light bulb is old. It's actually a new bulb. It's just that we might need to have this fixture, the whole fixture, looked at. So you know, these wires are kind of old, and this house is old, but it's okay. Everything's fine. So bear with me. Okay. Average, yeah, so you know what the drill is. It's average. Now, is it going to be in fish per hour, or is it still going to be fish? It says average number of fish, but it's an average, okay, per hour. So that's what we're talking about. So when we talk about that, we talk about 1 over, and then of course 5 minus 0, just to be technical, which is just 1 over 5. Okay, and we are going from 0 to 5. And instead of just writing this out, I've got this one in y sub 1, so I'm going to put y sub 1 dx. Okay, and I know it says x there, but anyway, we understand. And maybe just for clarity's sake, we might say from 0 to 5, L at t dt. Okay. And that's pretty simple. It's pretty straightforward, isn't it? Just think, when we see average number right here, we are going to do, oh, 1/5 right there. One thing you can do, you can find this and then divide. If you want to do it this way, you simply divide by 5. You can do that. Either way is fine, but I mean, it'll work the same. Okay, you get the same answer. Alright, was I able to keep that on my calculator? Let me see. No, I was not able to do that. Okay, so let me put it back in again. So it will take a little bit of time. I've had all this in there, the reason I thought maybe. Alright, let's see. Might have it. Alright, we are going from 0 to 5. And instead of y sub 0, I'm going to put in y sub 1. That's what I've got in there. Alright, so again, you want to get to y bar to get there. Alright, that's just so much easier. And I like to just find this answer first and then divide that answer by 5. And then that gets it right there. 6.059. Let's see how they to the 0. Yeah. 6.059 fish per hour. So it is going to be in fish per hour. Now remember, average is going to be still the number of fish over the time. Okay, so that's what you got to remember about that one. So this is about equal to 6.0. Let me see what it is. 0.059. 0.059, and just so you let them know that you understand what the units are, fish per hour. Okay, there it is, and that's letters A and B out of this right here. Okay, well, I'm getting ready to go again. We go everywhere, but this time we're going to work out. This is, yeah, I know, this is my workout t-shirt right here. I'll probably change my KP to Math G here, or just KP hat to something else. I don't want to mess this up. But anyway, hey, listen, everyone, I appreciate you being patient with me during all this time. I thought it was a very good lesson, and I think from there on, we're going to look at probably C and D next time on the 146th video next time. So please keep tuning in. I'm still alive. I'm still going. I'm still operating here. Hit that subscribe button if you haven't done so. Make a comment if you would like to do so. And hit that like button. I always say this, but I get a smile on my face even talking about it. The like button is really good. Okay, but again, this is not about me. Whether you hit the like button or subscribe or not, it'd be nice if you subscribe, but if you don't, it's about you. This is all about you. And it's not about my glory, but it's for yours, you know. I just get the satisfaction at my age of 63 of being still able to do this, you know. I try to keep up with it, and that's what you got to do if you want to excel. You have to keep up with it, whether you are a student or a teacher. And no matter how long you've been teaching this, you got to stay up with it. Alright, well, anyway, KP the Math G signing off. Ladies and gentlemen, have a great day.